Hello, everyone. Good morning and a very warm welcome to this month's Serverless Saturdays. This is Rashid Repakla, AWS Serverless Hero, and a part of Confirm. And I have Dharmendra with me, as always.
Hello everyone, welcome back to the new year and our new session for Serverless Saturdays. And yes,
As Dharmendra mentioned, New Year, and you would have seen a lot of reinvent announcements, a lot of new services, enhancements to the existing ones, and all sorts of things. And we are back here with a couple of exciting sessions. The first one being a little more interesting for me because I've been using step functions a lot, and I've had multiple sessions on step functions as well. And what we are going to have from the first speaker is about how we can probably get rid of step functions. I don't know. We'll wait and see and listen from Jaya. Dharmendra, you can introduce the first speaker and we can get started.
yeah, so we have two Power Pack session today, and the first speaker is Jaya Ganesh. He is application developer at Gency, and today he will be walking us through the durable functions with the step functions and the workflow. So, welcoming you, the Jaya.
Hey, hi Jaya, how are you doing?
Hi everyone, I'm good. How are you all?
All good, all good. So thank you so much for joining us today on a Saturday morning. And as we got to know sometime back, you are organizing another event, and parallelly you are here to share your knowledge with our community. Thank you so much, first of all, for your dedication, and we really appreciate you, we're really excited to have you here.
Thank you. Yeah, it's my pleasure being here.
Yeah. So over to you, Jaya. You can start with your intro, and you can kickstart the session.
Yeah, sure. So, hi everyone. As I was introduced, I'm Jay Ganesh and I'm application developer. Yeah, recently senior application developer. So, working with Genesis. My core area is completely on serverless and AWS, okay, and then cloud native. So, day to day, I just build stuffs on AWS serverless and then architecture things on cloud native way and then make sure it's deployed and the important part is it's all observable, so we make sure that whatever we do, it's deployed and we are able to monitor and everybody is able to see what is happening, the right context. So that's what I do. And yeah, I'm very happy to join here. And let me share my screen. Once you're able to see.
Sure.
Yeah, in the meantime, right, like, the reinvent, recent 2025 reinvent. So we had many exciting announcements from AWS. So one such announcement is, durable function, which I look forward to, and uh, we all have this, right? Like we do step functions to orchestrate many of the workflow what we have, and then sometimes it has been difficult for people, right? Like it's something new as an application developer, right? Like as a person who's coding, we know a language, for example, like somebody is from Python or maybe the JS, right? So usually we do in any of these two language, and then we kind of deploy and develop everything on the Lambda. And when people got introduced to step function, right, sometimes, yeah, it's kind of easy. It's a visualized workflow. It's like what you see and what you get. You can drag and drop and do all such stuff there. But getting to see all this stuff as a code in a single Lambda function is what, like, the durable function gives. And then we are also currently exploring this part of how it is, and then how we can use it very well in our production scenarios.
Awesome, Jay. Looking forward to the session, and uh, even I'm excited to learn about durable functions.
Thank you. Is my screen visible? Okay, I'm just sharing.
Not yet.
Oh, sorry, I think. Yeah, now it should be maybe.
Yes. Let me add it. Yes, we are able to see. The stage is yours, Jaya. Yeah. If you need anything, we are here. Just let us know.
Sure. Thank you. So yeah, again, welcome all. So this is a section about stateful serverless. We have seen serverless being stateless in many of the scenarios. So here, like we do have a inbuilt lambda. It's like lambda on steroids. Like it's a lambda with a cape. That's what Uh, durable function is. Okay. So I want to start with a question, right? See, here, like how many of us have built a workflow? It's not just a single step, right? Like we have multiple steps, and then they all communicate to multiple services in maybe AWS. And also we have logic which is tightly built on application. It's not something related to the AWS service or something, right? It's your application logic is tightly built. And whenever something fails, like we have to retry it. Okay, and it has to make sure that it is not duplicating, and it's kind of idempotent. Okay, so we would have all faced this issue. Okay, so and there is no direct way to achieve this. Yeah, we do have SQS, and then we can actually put it, and then we can have the retry logic. So it's kind of more on the infra side. Okay, it's on the AWS service side. Okay, and you won't be able to, when you use these kind of decoupled architectures, it becomes very much pain when you want to debug it and then see. And even the one such scenario is like testing it on the local rate. Yeah, we do have solutions for that, but yeah, it's kind of but difficult. And what I think is lambda durable function is what is going to solve these problems. It's going to address these problems, I would say. Yeah, I mean, as we discussed about the step function, I don't think so it is going to replace the step function, because that kind of handles a different set of
Hey, Jaya.
scenarios, and it's kind of
Jay, sorry to interrupt. We've got a few comments that if you can be a little more louder, it's a little,
okay.
yeah,
Maybe is it better now? I think I'm just
yeah,
going
it's
to
a little
increase.
better. Yeah, it's a little better. Yeah, if you can be louder, that'll be great. Yeah, thank you.
Okay. Yeah. Okay. Yeah. Sorry for that. Yeah. Okay. So I think let me continue. So I think this, right, it's not going to kind of, as I was saying, replace step function. So we have step functions handling different set of scenarios, and we also have lambda durable functions, which is going to address different set of problems. Okay, and this is going to help us a lot when we have our workflow which is tightly related to the application logics or our business logic. Okay, so this is what usually we have, right? A multi-step function. Okay, so we have multiple step, and what happens whenever something fails, right? Like there is a particular step got failed. Okay, and then what happens, like usually we retry everything from the step first. Okay, and then we have kind of reused or wasted some of the compute, and also we make some network calls to DB and all such steps, right? Which is happening again. Okay, which is kind of like you know waste of resource sometimes. Okay, yeah, we do have some decoupled architectures, like we can use dead letter queues and then queue and all those things, but yeah, it involves another set of level. It goes to the infrastructure. Okay, so usually, yeah, these are all the things which we do. So we use SQS chaining, and then we do step functions, and then for the state, right, like we usually have a DynamoDB setup in serverless, architectures, where we maintain the state of the application, right, like which step has completed. Okay, that's usually is present in the DynamoDB. Okay, so these are all the escape hatches which we use. Okay, let's see how to avoid this, and then how to get this workflow architecture inside the Lambda directly. Okay, here comes the durable function. This was announced in the reInvent 2025. Okay, the main feature, I would say, or the subtitle of this is the checkpoint and replay. So whatever you are doing, you can checkpoint it, so that your progress is saved, just like a video game, right? We play games, and then we kind of save it at particular checkpoint, and then we come back anytime, and then we are able to resume from that particular. Okay, and in that once the checkpoint is saved, and then like your character has maybe lost or died, and then you don't go back to the initial starting point of the game, right? It kind of like respawns from the checkpoint. Okay, that's what lambda durable function is achieving. Okay, so yeah, so this is one of the advantages. Like we write a normal code, so we are familiar with Python or maybe TypeScript, okay, so we can use any of these languages as a developer, and then I know the learning curve is kind of easy for the person to develop the durable functions. It's not going to be a YAML or maybe the Amazon state languages, so that it's kind of in your language which you know. And then it's tick pointer, and one other thing is the long execution, right? These function you can actually make it, wait, and then it can actually, the asynchronous functions, it can actually extend up to 1 year currently. Okay, and then idempotency is something built in this particular durable functions. Okay, so we have the replace, and then it's completely managed on AWS as the AWS Lambda. Okay, so currently it supports Python 3.13, 3.14, and then Node.js 22.24, and then a couple of days before, maybe day before yesterday, I believe, it got released for Java in the preview. It's not a stable still; it's a preview. So I think we are looking forward to that also. So usually what is the life cycle of this durable function? Okay, if we see that, so we get the Lambda invoked. So it could be either a synchronous or asynchronous, invocation. Okay, and then we have multiple steps. So in the workflow, whatever the step is there, so that will get executed, and that step output is kind of checkpointed and stored in memory. Okay, so that is handled. All these checkpointing and storing is all handled by the durable functions. It's all managed by AWS. Okay, and one other thing is suspend. Okay, so whenever we do stuff, right, like we sometimes we have done like sleep. Okay, so we put a sleep function there for so that our application can wait in the Lambda. Okay, so we are kind of like paying for the compute which we are not using. So when we use this wait functionality in the durable function, right, we don't use for the we don't get paid for that compute wherever it is kind of waiting. It gets suspended, and then like whenever a checkpoint is there, so it resumes and replaces from there, and then towards the end it gets completed. Okay, so this is the entire life cycle of a durable function. And then let's get started with how to create a durable function. So it's the basic same Lambda function console what we have. Okay, one thing is, if you see here in the step, so we have something new called as durable function, and we have an option to enable it. Okay, and one thing which we have to keep in mind is like we can only enable it at time of creation. Like once we have created some Lambda function, we won't be able to convert it either way, either to the normal or maybe the durable execution. So you have to set it up before, like you have to check this checkbox when you are creating the function itself. Okay, and then when we are going with the infrastructure as a code, yeah, not everybody is doing this and manually, right? So we are using serverless application model or Terraform or whatever it might be. So we have just added a new key, which is durable config, is added to the particular resource. And then here we mentioned the retention period in time and execution timeout. So execution timeout is the overall duration of which your durable function can run. Okay, so when it is a synchronous invocation, it is going to be 15 minutes hard stop as we have for the standard Lambda. Okay, for the durable config, however, we can extend it up to 1 year. Okay, and then we have this retention period in times. That is where, like, these durable executions, okay, they are checkpointed and stored, right? So how many days you want to have it in a durable state, so that it can be replayed, or maybe you can check it. Okay, that's what it is. And then this role, right, AWS Lambda basic execution role, I think we all know we would have created that. Okay, so we have something very similar for this durable function which is required. So this service role, it see left hand side, you can see the create log group, log stream, put log events. These are all the basic CloudWatch feature which you need. This has to be there in the Lambda so that it can communicate and send the logs to the CloudWatch logs. And then if you see on the right hand side, we have two, that is like Lambda checkpoint durable execution and get durable execution state. These are all the two policy permission which you need to add, so that your Lambda durable function works as expected, or else it won't be able to store and get the state. So this is a standard Lambda. Okay, how we have, if you see here, it's a very simple Lambda. It's not, if you see here, like we have just I have just added a custom step here. I'm just like saying it's like a hello world step, and then I'm returning some response from it. Okay, and then I have a Lambda handler. Okay, so, and then inside this I'm calling that step, and then I'm doing a sleep here. Okay, And if you see here in this sleep, like it kind of waits in the lambda, and then we are getting charged for this execution. Okay, this is your standard lambda function. Okay, let's see the same thing in durable, how it looks. If you see, the core logic remains same, but I have added some decorators to the functions. If you see, I've just imported few stuff. First, let's go with the handler right here. So in the handler, if you see, you can find out something called as durable execution. Okay, so this decorator is compulsory for the lambda handler entry point. So we have added this, and then we have added the context. And then next step, if you see here, I've added something called as durable step. So all these custom functions which we have, these steps, we can just decorate it with the durable step. Okay, and then how to call this step? Previously, it was like message equal to custom step. Here, I've just added context dot step. So this context is the durable execution context, and it has few SDK functions. So one such a step, and then here if you see, it is context dot wait. So it waits for 2 seconds. Okay, and then and then I have some console logs. So when we see this here, so this wait, whatever you are doing for 2 seconds, we are not going to pay for that. That's something great. Okay, let's see. So maybe I'll go to the console. I think I'll invoke it and show it to you how it looks. So this is the same durable function which I have created. So what I'm going to do is, here if you see for the standard function, usually we find code, test, monitor, configure, alias function, right? We have something new here which is called as durable executions. Okay, so here what I'm going to do, you can actually go to test. So we have two types of invocations, synchronous, asynchronous. You can put your event here, and then whatever the durable execution name, right? So you can put some name here. If you don't put, I think it's by default, it's auto-generated for us. Okay, I'll talk about the importance of this execution name, in upcoming slides. So I'm just clicking the durable function execution here. We can actually see. If you see here, we can actually visualize what has happened in the function. Okay, so I had a function which called as custom step, and I'm having a delay. Okay, the name of the step is delay, and then what it is doing, it is a wait, and then it's a step. The first one was a step. Okay, and then here, like we can see what has happened, the execution history. So at what time what started, what failed, or maybe what got completed successfully. All those details we can see in the event history. Okay, this is always available when you go to the durable executions here. Down right, we have all the history of executions here. You can find everything back. Okay, so this is what I was showing. So we have the custom step, and then we have the event histories available in the Lambda console. Okay, so yeah, I think we got introduced to the durable function, what it is. Let's go a little bit deep about what are the building blocks of the durable function. Okay, so in SDKs, I think we just saw what is we saw this wait, right? It's a context dot wait. This is, yeah, it usually kind of differs for each programming language. Here I'm just focusing on Python, but yeah, but it's kind of something similar. The concept is similar, only the syntax change is there. So if you see here, context dot wait, it's kind of like suspense without building. And then this is how you kind of add it. And then for example, in some scenarios, right, like you may have, you're onboarding some customer, or maybe you're onboarding some employee into your application, and you want to have some cooling period, or maybe you want some verification done, and then you want some cooling period there. Okay, so usually what you can do, you can put a cooling period of 24 hours or something like this, and then have your custom logic. Okay, or maybe you have done some step, you have executed something, you have sent a notification, and the person has not responded. So what you do, you wait for 24 hours, and then you send a reminder to the person. Here for this 24 hours, it has, like usually what we do, we have to decouple everything, and then we have to maintain the state in somewhere outside. So this has made our life easier in this case. And then we have some other features, something it's called as like parallel. So we can actually run multiple steps parallelly. Okay, so usually, yeah, we check the inventory, we check the pricing, and then we also can verify whether that authenticity of the with the purchase, all those things. So you can do the fan out and fan in. And the another attribute which I want to mention is we have something called as max concurrency. Here we don't want to run or flood the systems, right? Like we can set the max concurrency here, and then make sure that it is running as expected. And one other thing is, invoke. So it is like invoking a another lambda function. So we have, we can consider this workflow, the durable function, as just a workflow, and then build some custom logic or microservices in some other lambda, and we can actually directly invoke the lambda and get the response. Okay, so for that we can use the context.invoke. These are all the built-in methods which are available in the durable context. And then we do have a map. So whenever you have having an array, a dictionary, a list of data, and you want to process them, so you can do the map, and then you usually invoke the process item. And then here also we have the max concurrency. And when this is done, so this here, like, it waits for everything to get completed, and you can see the results of what has happened. Okay, yeah, and then we have wait for callback. So this is something like, when you need a human in loop, right? Like you have a job which is running, or maybe some analytics, or maybe it could be anything, right? Like you are running something and you want it to be approved or verified by some human. So what do you do? So you can actually create a callback, okay, and then have a custom function which sends the approval, email, or maybe notify somebody in the Slack, or maybe any of your system, right? And then they can actually verify that, and then they can confirm either they can approve this or reject it. Okay, so after that, based on that humans input, so this you can fan out and then branch it out and then continue. And then we have something called as wait for condition. So this is also like, we do, right? Like we make an API call to a system, and then like we submit a job, and then we poll kind of every 5 seconds, and then we do an exponential back off, and then maybe we hit like after 10 seconds, or maybe we retry in a given period of duration. Okay, so for that we write a code. So to simplify that, we have something called as wait for condition. So here, when the condition the status changes to completed, so this kind of steps gets succeeded. Okay. So, and like we have given here, like what is the delay? So you can set the delay, and then whether what should happen, whether it failed. So all those configurations you can give it here. So this is what like wait for condition is for. So these are all the 6 operations, okay, which are the building blocks of the durable context, and what makes the durable context, stand ahead. And the next thing is, right, idempotency. So in case of durable functions, it's not something you attach, okay, from externally. It is something built in the durable function itself. Okay, so I was mentioning about the durable function execution name, right? Like that. So if you see here, we have in the AWS CLI Lambda invoke, we have a new option which is called as durable execution name. Okay, so this particular key is what is used to make this particular execution unique, and this is the key used for idempotency. Okay, usually, for example, let's say like you are processing some order, we can give the order number as the execution name. Okay, or maybe you are processing some payment, give the payment transaction ID, or maybe the whatever the trace ID you have, you can give that as a durable execution time. So whenever the execution name is reused, so it goes into the same execution, whatever is there in the memory, and then it is kind of reused there. Okay, so we can just see this in live here. Okay, what happens? For example, I'm just going back to my AWS console. Let me refresh it once. If you see here, this particular lambda function, this durable function, has a wait of 2 seconds. Okay, so I'm going to give here, AWS. Okay, so it's nothing. It's just the hello world. So I've just given this execution name. I'm just executing it. So what we expect here to happen is, if you see here, uh, step 1, it got completed. The next step was a wait. Okay, and then here we can see in the timeline that this took the duration of 2 seconds. Okay, as expected, right? So it waited for 2 seconds. Okay, so what will happen when we execute same with the same execution? We execute this lambda, the same execution. So let's do the same thing, right? I'm just going to copy it. I'll just refresh it, right? Like, just to make sure that it is not working the same. Yeah. See, I have refreshed it, it's completely same. It's completely different. And I'm going to give the same durable execution name. Let me invoke it. It completed very quickly if you see here. So what has happened? Let's see here. It kind of reused the same whatever was there before. Okay, since this first step was succeeded, it just took the output from first step what was there, and then this delay anyway it had in the previous execution it had already waited. Okay, so you don't need to wait again. Okay, so since it was the same name, right? It's both basically both are the same. So it's kind of invoking the same execution. It's like using the same execution. Okay. In the durable executions, we can actually click on this custom step what we have, and here see few things, right? Whatever your step is kind of returning, right? This is the this output is what's stored in the durable context state. Okay, and then every time when this lambda replays, it come to this step, and since it has already completed this step, it sends the same response back. So this makes sure that we are not something computing again, and we are using the same uh, output which was there. Okay, and then here if we see we have something called as logger output where all these logs you can actually see which got emitted from the durable context. Okay, so yeah, so I think yeah, one of the what are the advantage, like we are not going to pay again, and then like you're sending an email when it is inside the durable step, right? It's not going to call again. So we make sure that it is sent exactly once. Okay, and then yeah, DB read writes, so we make sure that they are handled properly, and even sometimes read, right? Like write we tend to make sure that it is kind of idempotent. Sometimes read also, like for maybe the checkpoint time date, like maybe yesterday but that particular time what has happened. Okay, so you need that particular read data. Sometimes like we do get these edge cases, right? Like so in those particular scenarios, whatever has the step has completed, we can use the output of that step, and then like even when you replay it tomorrow, it will use the same read output what was there from the DB. And let's see what are the golden rules, right? This is like what we have to remember always when writing a durable function. We have to write always a deterministic code. Okay, so whatever the side effects which your function is emitting, it's kind of creating, right? So if your function is creating a side effect, it has to be definitely inside a context step. Okay, it can't be outside here. When it is outside, if it's not inside the context dot step, what happens is whenever it's kind of invoked again, it runs. Okay, it's very much similar to the lambda handler in the standard lambda, right? Like whatever is there outside the handler, it gets invoked when the lambda container is kind of spinning up at the first time when it is cold starting. Correct. Inside the handler, whatever it is there, it is going to run every time. Okay, the same thing is kind of happening here. So if it is outside the context dot step, if it is directly there in the handler, it is going to run all the times, no matter what. So whatever you want to, make sure that it exactly runs once, so you need to put it inside the context step. That's what like we need to remember. And then like all these like we do generate a UUID, or maybe like we can actually do the date. We get the date time, right? Like all those things also, it has to be definitely inside the context step, and like the environment variables or the feature flag or anything it could be. Okay. So whatever you are generating, so it has to be all inside the context dot step. That's what like we need to remember always. And then, so if you see here, how the retries or time modes or error are handled, right? So first step. So let's see about the retries. So if you see here, like I have a step here and it has failed, for example. Okay. And like let's say our downstream system which you are calling, it's not like resilient as expected. It is failing. So we can set up some retrace strategy, how many attempts we want to make, and then how like between each execution, like how much delay you want, and whether you want to back off, like you can put the exponential delay. All those things you can handle it. Okay, all these are kind of provided by the durable context SDK, and we have all these in inbuilt in this particular setup. We just like need to add these particular properties, and we are good to go. Okay, and then so whatever the error rate, like each step error, like we need to make sure like we are catching it properly. Okay, and one more important stuff is like if you see here, the durable config, okay, as I mentioned initially, so the lambda has a standard lambda has a timeout of 15 minutes. So same, so whenever this durable function, you are invoking it synchronously, we do still get the 15 minutes timeout. The durable function can't go behind that. Okay. So whenever we are invoking it asynchronously as an event based, okay, it can go up to 1 year. Okay. For example, for some step, if you forget to set the execution time, okay, and something has something has happened in your code, and then like it's kind of like stuck in some particular state. Okay, if you don't set this durable config as expected, like as our application is expecting, right, like to some particular time, it can actually extend up to 1 year, and it will be stuck at that particular step. So which we want to avoid. So think about your architecture, what you are building, and then think about the application. So what is the requirement? Based on that, we can just set the execution time. So what are the limits? So what we discussed now, so it's 1 year for asynchronous and then 15 minutes for synchronous. Currently, it just supports like Python and Node.js. Just a couple of days before, Java was added in the preview. And this can be added at the function creation. Okay, you can't add it after. Okay, and then you can also switch the standard lambda function into durable, or maybe the durable function into standard. Okay, you can't go the other way around. So it has to be uh, checked at the point of creation itself. Okay, as of now, the cross-account invocation is not supported. Yeah, and then the lambda destinations. Usually for the lambda side, we do use lambda destinations. Like we send the success or failures, all those steps, right? So currently it's not supported, so we need to use DLQ instead. Okay, and then another important thing is the size limit. This 256 KB, I think we'd have all heard, like it's very much native to AWS recently, and yeah, many services got upgraded to an MB, but still these steps, right? Like each step, the output is stored in the durable context. So the limit of that particular step is 256 KB. Okay, so usually when our data is huge, and like so usually what we need to do, we shouldn't kind of send the entire data. So if we have something big, right, like we can kind of store it in S3 or somewhere, and then send just the reference to it. Okay, so that we don't hit this particular size limit of the steps. So, and then the next the comparison, right, like even the step function kind of achieves the workflow, and now we have something new, okay, which is like durable function. So what are the kind of difference between these two, and when to choose what is what we'll be seeing here. So first, right, let's go with what kind of like how you create or define the step function or the durable function, right? Durable function, it's an application base. So whenever it's like you are familiar with Python or maybe TypeScript, and you want to write everything workflow in these languages, then durable function is what you need. And then step function kind of uses the Amazon state language or the YAML, right? Like you need another set of languages there. And then local testing, yeah, you can do the SDK. Using SDK, you can do the durable functions, and then like for step function, we have lambda functions. Okay, and then yeah, when you want to call another interact with another AWS service, right, like maybe S3 or DynamoDB, or it could be anything. So for it, since it's in the lambda and we are using Python and TypeScript, we use the native SDKs of AWS and then interact with the AWS services. And for step function, yeah, we don't need SDK, we don't need to write anything. So it's like what you see and what you get, like we drag and drop, and then you're good to go there. And then so step function gives us the visualized workflow, so you can actually see the entire workflow and then build it. Just maybe drag and drop. Like we do have the visual builders, right? And then yeah, durable function as a standard, so it's completely code. Okay, and then yeah, we have some few things like which are present in both, but yeah, the major difference I would say is like this is completely on the code, and then like we need to use the Boto 3 and step, and there we have on step function side we have Amazon state language, and then YAML based definitions created. So when to choose each, right? So I would prefer durable function. When your workflow is tightly coupled with your application logic or code, you are not much interacting with the AWS. Yeah, we do make like a few API calls to DB or something, but yeah, it's not tightly coupled with the other AWS native services. and your particular workflow is like mostly tightly close to the business logic we have. In those scenarios, definitely durable functions would be a great choice, and I would recommend you all to try it out and see like whether it makes sense to you. Okay. And then like as the sub function, like we need to interact with the service, and then you can drag and drop. You need a visual builder, and you're not going to write any application, like, or not any, like very a huge application logic into that. Okay, if you're just kind of tying between multiple AWS services, then step function is a great way to go there. And then yeah, so usually, yeah, as I said, like this is basically the lambda, and then the event driven choreography style. So these are all the points which we need to keep in mind when we want to choose between a durable function or maybe a step function. Okay. So what is the pricing rate of the durable function? Since it's in the lambda, so we do pay for the compute of the lambda. So whatever is the standard lambda billing price we have, so that still applies. Okay, and then we have something new, which is called as durable operations. So we pay $8 per 1 million operations. So like each step which is tick pointed, right? This cost is for storing the each step and the state of the step, right? And then replay. Okay. So to that, like you pay $8 per million operations. And then definitely you need to pay for the data retention, whatever is stored in the context state, right? So that's why like adjusting the retention in period when you're creating the durable function, and then even the execution timeout. Okay, all these things you have to choose it wisely so that like you don't overpay. So what all that? Okay, I think before this best practice, let's see a demo, and then I'll go to the best practice. Okay, so I have created a simple demo. Okay, it's a kind of expense approval, right? Like we you all like you would have purchased something, or you would have done something, and then you submit your expense approval in your organization. Okay, so I'm just going to kind of mimic the setup here. Okay, I'll focus more on the durable function part, like how we can achieve, how we can actually put all together and create the complete the puzzle. That's what I'm going to show. The flow is going to be like this. Okay, so the employee is going to submit a report. Okay, that is going to be a validation. So for example, you uploaded a receipt. Okay, so we have you do an OCR, or maybe an a model which is kind of like extracting the text from those particular bills what you have submitted, and then you usually have the bill number, the date. You check for the date whether it falls under the current policy period, all those stuff, and then you cross check whether the amount is present, and whatever is present in the bill is same as whatever is present, what else employees has entered in the expense, right? So we need to do some validation. That's the next part. And then we usually what happens is next, whenever the approval is in some particular range of amount, sometimes get auto approved, or sometimes it goes to a manager approval, or sometimes it goes beyond that too. Okay, so that's the next step. And then so whenever this approval is required, so what happens, this durable execution, it waits there, it suspends the entire compute and waits for the approval or the rejection to come back. Okay, here we see how the callback is used. So basically the manager or the person who clicks whether they can approve or reject, and then the particular callback token is used and then sent back to the same execution. So based on this, whether it's approved or rejected, we check it. When it is approved, right, we send, you can send the, maybe like in this example, what I have considered, like we make a call to one ERP system. Okay. And then all these payment transaction, all those things has happened. So for that, like I'm just like trying to make a simple API call to the external system. And once that is done, so we send a notification to the employee who has submitted the expense saying, the expenses may be approved. In case if it was rejected, directly after the approval step, it goes to rejected. Okay, this is what I'm going to cover here. Let me just show the. Yeah, I hope it is visible. clearly. Okay, so if you see here, so what I have done, I have added a durable execution handler, okay, to my Lambda function. And then this is my first step, what I'm doing. Okay, so basically based on the employee number, right? So I'm making a DB call, okay, to get the approval chain based on the employee ID. So we get to know who is the manager to whom, like if you want, like whom the approval should be sent, if it has
Sorry
specified.
to interrupt, Jaya. Can you increase the font size one level? Yeah, better. Thank you.
Is it okay? Yeah.
Yeah.
So yeah, so I have added this step also, right? Like as I was mentioning, it's not just the DB rate sometimes, right? Like you can also get and cache the DB reads also based on your scenarios, okay, based on your requirement. So here what I have done, so it's basically a simple function which kind of queries the DB and gets the email IDs and then the approval chain for that particular employee. Okay, so this is my first step. My next step is, okay, in this expense, the user employee would have submitted multiple receipts, right? So we want to check the receipts and then see the expense amount, all those stuffs. Okay. So for that we have OCR. So what you can do, these can run parallel. Okay. If they have 10 number of receipts, like you can do three or four in parallel, so that, or maybe even sometimes like you can also do the 10 in parallel and get the response. You don't need to go, one by one. So for that, like here we are using this context dot map. Here I'm sending the list of invoices, receipts. Okay, so it's basically the URL. Okay, so and then like I'm calling a function which is extract receipt. Okay, so here this sends the particular URL and then the index of the particular receipt. So this kind of like it kind of mimics actually as of now. Okay, so it mimics the OCR capability and then it sends the response back to us. Okay, so this is the step number two. Now we know what is the amount mentioned in the each of the receipts and like total. And then like here, there is an, you can put an anomaly detector. Okay, so basically it will kind of check whether that receipt is original or fake, or maybe these all these numbers are matching or adding up, right? All this you can actually put it in a separate function as well. So what I have done here, I have created another lambda function which kind of takes this inputs, what all the past receipts, right? The data is taken and then the total claimed amount. Based on this, this is another altogether a different lambda itself, which is a standard lambda function. It's not a durable lambda. Okay, so this durable workflow in the step three, it invokes another lambda and gets the anomaly response of what it is. Okay, and then we kind of like do some validation here whether that amount is good, all those based on the response rate, all those is good. And then if everything is good, okay, okay, yeah, if there is some anomaly detected, so first we send a notification to employee and reject it. Okay, so for that, if you see here, I have a step. Okay, so basically usually what we do, you just like put this particular function to send a notification, right? So we just like need to wrap it with the context dot step. That's it. Okay, so I'm just giving this callback here and then naming this particular step as notify employee anomaly. That's it. Okay, so this is the next step. So now like if the anomaly is, there is no anomaly detected and everything is good to go, so then like we have another step. Okay, here we have the expense summary, and then we have another step which says, what should happen, like whether what should the approval be. So here I'm having another just wrapping with the context dot step, and then saying this is the what is the approval tier it should go to. Okay, so if it is auto approved, we just leave it. If it requires manager approval, okay, we invoke another step. Like here, if you see, we can actually have the another step also put into that, branch it out. And then we also have, if it is requires another step, it's going to another different like person, right? Like we for like the amount greater than, you can set the thresholds and then we can do all this application logic here. Okay, and then once the approval is okay, so let's go to this particular step. Yeah, so here I've created this callback. Okay, so what here we have created this callback and then we send out a notification to the particular person, and then the person can either reject it or approve it. So for that, till that, like the application has to just wait. That's it. It has to wait for the callback result. And when we do this, right, we are not charged for the waiting duration. Okay, so it just suspends there, and then once the request is received, right, it just resumes from that. If you see here, the first step, what we need to do, we have created a callback, and then we have sent a notification to the person who needs to approve this, and then we wait for the callback result. That's it. Okay, this is what I have done here. Let me go back to the. Yeah. So once this is done, once we receive some response from the person who's approving it, I'm just branching it out. Okay, and then in case it is approved, so we have very simple step like context.step. It's like post to ERP. Okay, here, to make this interesting, what I have done is like I've made this post ERP to always fail at the first invocation, so that we can see this, this retry kicking in and see how it works. So I've given this retry config, right? Like this particular step, all the step can have a step config. Okay, so here I've given the retry strategy, and it says like how many attempts it needs to make and what is the delay, and then like what is the backoff rate. All those things you can mention it here. That's it. Like with this, you don't need to actually retry all those stuff in your application logic right here in your function. It's just a simple function, and here we have given the retry and everything here. And once it is submitted, we just send another notification to the person saying like, yeah, so when it is approved, yeah, we just send the notification to the other person. It's also another step. Okay, so if you see here, the important SDK functions which I've used is like context.step, and then we have used callback, and then one more thing is context.logger. Okay, so there is an inbuilt logger which is available in the durable functions. So when we use this, right, it kind of avoids the noise, right? When you use the normal print, okay, so and then or maybe the normal logger, so it kind of locks every time, and it can sometimes clutter the CloudWatch logs. So when you use this logger, it makes sure that it doesn't clutter and you don't kind of have multiple logs in multiple subsequent executions of the same durable execution name. Okay, so this is on high level what we have done. Let's go to this particular lambda. If you see here, I have 3 lambda functions. Okay, so this is the report workflow. This is the workflow which we created, which I showed. So this is the durable one. So I have deployed it, and then I have an anomaly detector, which is a simple lambda. It's just going to always return, true. Okay, no, so it's like everything is like good. That's what it's going to return. And then we have a callback handler, which is kind of listens to the expend the approval or rejection, and then sends that response to the report workflow. Okay, so I'm going to the report workflow, and then let's go here. Yeah, one of the important thing is when you need to invoke this lambda durable functions, you need to invoke it either with a version number or an alias. Okay, you can also put, you can invoke the latest version. Okay, but it is always recommended to use a numbered version. Okay, like this 31 or maybe the alias product. Okay, it's always recommended to use this particular version, so that even your when you invoke retry something after few days, it's not using something like the application, for example, it would have changed maybe a couple of days before, and then it's not going to use the latest one. It's going to use the same execution version which it had run previously. To make sure that, it's always recommended to use the numbered version and invoke based on the numbered version. Okay, so what I'm going to do is I just have some data. Okay, I'll just show a couple of invocation, and let's see how the execution shows. So this is a normal execution. Okay, okay. The scenario is like it's kind of like 350 amount. Like for this, I've given it as like auto approved. Okay, so I'm just going to give some random execution name, and then I'm going to invoke it. Okay. So yeah, now this particular lambda has invoked. Just go back to here, and then we can see the durable executions. We can see this particular one got invoked now. then we can see each of the steps here. Okay, so whatever I have done in the application logic, you can actually check here and then visualize it, and then you can know what time it started, failed, or completed, and everything. Okay, and here if you see, so in this case, like I sent two receipts, right? In the payload, if you see, I have two receipts. So it has branched out into like two, and it has kind of run this particular step OCR receipt parallelly, and it kind of gets the data from that receipt. And then next I have an away director, which is another lambda altogether. It's a standard lambda. So we invoke this lambda and wait for the response there. And it also could be a durable function. You can actually also invoke a durable, another durable function, chain it together. Okay, and then we have another step, and then we have post ERP. So if you see here, we can see this particular red here. So to make it interesting, right, I've made this post ERP fail it on the first string, and then it will retry again. So we can check those event history. If we come here, like each step what it has taken, we can see here, and then this particular step, right, post ERP, it started first and then it failed. You can see the details of what was the failure and everything, and then again it retried. Okay, and then it got approved, so it got succeeded, and then it went to the next step. Okay, few things I want to show you here. For each step you can click on the step and click on the output. Okay, so whatever that step output, right, you can see that this is what is kind of checkpointed and stored in the durable context. Okay, and you can see if there were any retry items, you can see those. For the post ERP, so this was the original one, it failed and then it retried again and it got succeeded. What was the error? We can see it here directly. Now let me just invoke another scenario and show it to you. So this will kind of use the callback what we had set up. Okay, just giving some random execution name just to make it unique, but usually here it will be the expense ID which is getting generated in our system from where we are invoking this durable function. Okay, so in this case, if you see, like I've executed again, I'm coming back to the same durable lambda function. Let me refresh it here. Yeah, so if you see, this has started running. Okay, so let me click on this. You can see all the details. Okay, but if you see here, we have a step which is called as callback, and it started. Okay, so what has happened? So it went through, and then we found out that we need some approval for this step to proceed, and a callback was generated, and then that particular callback details was sent to a person so that they can approve it or reject it. Okay, so we have something in the same callback step, an option to either send success, failure, or all these things, right? But let's I have set it as set up email to receive. Yeah, so I have received this. Okay, so basically it's auto approval. Yeah, so I'm just trying to approve this particular response since it gets approved. Okay, so we can see what has happened. I'm just refreshing the same. If you see here, this got succeeded, it got resumed. Okay, and then the post to ERP started, entire thing was complete. Okay, so this is the power of durable functions what we have. So let's see the best practices what we need to follow when creating the durable functions. Okay, so as all the side effects has to be inside a step. Okay, and then all the non-deterministic code, you are generating something randomly or timestamp or anything, that has to be always inside a step. And the execution name, right, this is what is used by the durable functions to make it as idempotent. So you have to have something like a business key, right? Like you can have the payment reference ID, order ID, or maybe the user ID, email, or it could be anything. Okay, so you need to make sure that based on your business requirement, you select this particular key accordingly. And then the numbered version, right? AWS still allows you to invoke it with the $latest, but it is not recommended. So you need to always use a numbered version or an alias in the production scenarios. so that it even if when you replay it or invoke it again after some point in time, you make sure that the same execution of the particular yeah, sometimes like you need to run it on the newer code, but that's fine. Like, but if you want to run it on the same code what was there maybe a couple of days before, when we use the numbered version, it makes sure that it does. And then we have to have the timeout and then give the steps the meaningful names, right? Like when you say it, like you should be able to visualize and then easily able to figure it out what was happening. And then use the context.logger, which is available in the durable functions. And then like the state, right? Like as I mentioned, each step has the limit, size limit. So if it's something small, it's good. But if you are expecting something, the data to be huge, so store it somewhere and then send the reference back to it. And then always you can test this locally, so that's like always test this locally, since it's your python. It's kind of like in python, like you can it's compatible with pytest, so you can write the test cases and then test it and see if it works as expected. Okay, so yeah, that's it from my side. I hope you had a great time, and you can connect with me on LinkedIn, and then if you need any questions we can you know talk later to post. Shushwat and Dharmendra, take it.
Yeah. Yeah, hey Jaya, that was a really great session, especially for someone who's not experienced with durable functions. I think this was a very good Kickstarter, especially the part where you talked about the best practices towards the very end. I think that's really important and very well covered. So, first of all, thank you so much for this amazing session. So, I'm just checking if you have any questions in the meantime, Dharmendra, if you have anything to add.
Um, yeah, means it was a really nice session on durable function, and yeah, it was new for me as well. I have not tried yet the durable functions, and I just want to check on one thing. Like in step function, as you mentioned, there are steps where we can add the different services. Now here in durable function, you show us the different lambdas. Um, I missed the stitching part somewhere. So how the lambdas are stitched together, or they are uh, like how that part is being done?
Yeah. Okay. Yeah. See, two things, right? You mentioned Lambda as well as like other AWS services. Okay. When you want to call other AWS services, it's similar way how you do in their Lambda function, right? Like we use Boto3 and then invoke the other Lambda function. Okay. But we can still wrap it up in the context.step so that it's considered as a durable step. Okay. And then to invoke another Lambda, yeah, I think, a lambda calling another lambda, some people say that it's some people are say it's not good practice, right? Like synchronously you should not call a lambda from another lambda. You are paying for both. So we have this context dot step. So what it does, it invokes the other lambda, wait for that lambda to come back with the response. It's kind of like call back and then wait mechanism, right? So you can still do that. Okay. So yeah, so what we did in this particular demo, Dharmendra, so we saw actually how you can stitch the lambda using the dot invoke method. So usually what we can do, we can use this context dot invoke, okay, and then we put the ARN of the lambda which you want to invoke, and then inside this data, right, whatever your uh, input payload of this particular lambda, you can actually put it here and then invoke it. And then this is just the name which you want to see and visualize in the durable execution, console.
Okay. Um, and when we invoke like as you mentioned, we are invoking the lambda, and it you wait for the response, right? And sometime let's say there is a failure, and uh, what bad practices says that we want to wait for the response. We assume that it's like in most of the cases, like async, when there are async cases, we don't wait for the response. So uh, how do you handle that part, like if lambda is taking more time to respond, something like that?
Yeah, so it's more or like a callback, right? So it kind
Yeah.
of suspends and waits there. Okay, so till the lambda response, and if it fails, you can do a. We have an option to we can add parameters to retry. Okay, that is one thing. And then if it fails and like you are expecting that failure, and you can still like, since it's your application code, right? It's your Python code or TypeScript code. We have the full control over what we can do there, so we can actually catch it. So I mentioned like in a couple of sites before, each step you can try expect except block, right? You can use those also in case of you are expecting some failure and you want to handle each failure separately.
Okay, and there was one more part you mentioned, idempotency, which was interesting. Earlier, we used to have different services to handle it. Now it's an
Yeah.
inbuilt part of that durable function. So, can you explain a little bit more on it, like uh, how, like it is per execution, or like there are different steps under Lambda, right? So, how it handles for the particular execution?
Yeah, I think that's a very great question. That's what I think this particular this is also trying to achieve. So we saw that each execution has an execution name. Okay, so you can give a name when you are invoking a lambda for that particular step, a particular like lambda invocation altogether. Okay, it's not linked to a step. Okay, so when you give that particular name, that is your unique ID which is used. Okay, so usually what happens, like in the payment, for example, like you order something. So what we do, we take that particular order ID and then use that order ID and pass it to all the steps and make sure that you are not making the customer charge twice, or maybe not sending the email multiple times, right? Like you usually have that particular ID, for example, stored in a DynamoDB, and you can say email sent, yes, payment completed, yes, something like that. You can maintain, you can checkpoint. Okay, usually that's what like kind of, not exactly, but that's what usually we do. Okay, so what happens in durable execution is, here I gave this as my expense ID. So this will be your unique ID for that particular invocation or the transaction. Okay, this is like a business transaction, let's say. Okay, so what happens every time you invoke, maybe you are down, the system which is calling you, so it has called you again. Okay, maybe after some time due to some mistake, and since it called with the same execution name, okay, so what happens, Lambda recognizes that and then it goes back into the same flow. Okay, kind of like it got triggered, and if it is already running, right, so it will see like in what step it was there, and then it will just like continue from that particular one. And all the steps which are checkpointed here, okay, for example, we run it now, we kind of run it again. These steps are not run, you know in all these subsequent requests. So all the response which is there here in the output, it is used. This is what makes this thing idempotent. It doesn't matter in number of times you call, even after some couple of days, we use this execution name, the whatever the order ID or whatever it could be, as our unique identifier of this transaction. And this makes sure that it is not run again, and you're not charging or maybe sending emails or maybe doing any API call multiple time unnecessarily.
Yeah, it's really nice now. Like inside one umbrella, yeah, you are getting it everything.
Yeah.
So, yeah, Jay, there's no specific questions from the audience, but I have a couple. One is with step functions. One of the biggest challenges was the local testing, right? Especially given that there are so many services that we are orchestrating with. Ensuring that we are able to test it out locally before even pushing it to AWS was a big pain point, and then AWS launched this step functions local, which we could leverage and test out and everything. So I know this is still orchestration within the code, so we can still test it out. But for cases like the callback pattern, right, where we have to wait for another a service to respond, or the human in the loop situation, how does the local testing happen in these scenarios and cases?
Yeah. So usually what we can do is, in the callback rate, we do get the callback ID, and we can stimulate the, in the PyTest itself, we can, stimulate a rejection, or maybe we can stimulate, approval. So all these callbacks, right? Since it is in the application code, we do have these PyTest modules and then
Right.
decorators and methods, right? So as a developer, it becomes much more easier because it's the language what we speak already. So we know these test cases, how to write all these tests, right? So we don't need to do something or learn anything extra. So it's what we do daily. We just like need to start using this SGK. That's it for the PyTest.
Got it. Got it. Yeah. Thank you so much. Yeah, it was a wonderful session. I'm sure I've learned new things, and so has our audience. So thank you so much once again joining us today, and looking forward to having you again sometime in the near future.
Sure. Thank you all for the opportunity.
Yeah.
Thank you.
One last thing, Jay. I think you had the code samples, right? If it is available on GitHub and if it's something that you can share in the public, please do share it here in the chat or. So yeah.
Yeah, sure. I think I'll share the deck and then the PowerPoint and also this code, right? Yeah. I think it's
Yeah.
not at the latest. It's not at pushed yet. I'll push it and then we'll share it.
Absolutely. Absolutely. That'll be great. That'll be great. Thank you. Thank you so much. Yeah.
Thank you.
Thank you.
Okay. So that was an exciting session, especially something new that was launched about a couple of months back. And I'm also here to try out, as I mentioned, we have a lot of step function related use cases in our organization. And one of our critical flows runs on step functions. And I'm actually looking forward to migrating it to durable functions for all the various advantages that Jay has already covered. So before we jump into the next session, I just wanted to quickly share. As you see from the chat, from SVC Tirupati, the students have joined. Glad that the students have joined and are gaining knowledge as a part of the sessions. So before we start, just one last thing I wanted to do was we are going to do an in-person session in Tirupati next week, which is next Saturday. It's going to be a workshop on Kiro IDE. So I'm just sharing the link in the chat. It's a free workshop, of course. So please do register if you are planning to attend. It will be in MBU. And looking forward to seeing you folks. But please do register only if you are attending, because that helps us with planning for the logistics and everything. I've pasted the link in the chat here. So yeah, looking forward to seeing a few of you over the in-person workshop next week at Mohan Babu University. So yeah, I think Dharmendra, next we can invite
Yeah.
the next speaker.
Yeah, so we already have a second speaker in our lobby, and so our second speaker is Amin Ali. He was my previous colleague also, and now a good friend. So today he will be walking us through with the personal AI assistant bot, how to develop it with Amazon Nova and Cloud Bolt. So welcoming you, Amin, to the Serverless Saturdays.
Hey, thanks for introducing me. So first of all, good afternoon to all of you, to both of you especially. Okay, so thanks for inviting me here.
Yeah,
Thank you.
thank you, Amin. And for folks who joined the AWS Student Community Day, which happened, I guess, what a few months
Yeah,
back, and you would have probably heard Amin in his session, a really hit session for his bot that he had built. So yeah, thank you, Amin, for joining us today. And you're going to talk about something that is on the rise now, like crazy popular. I mean, it was so popular that they had to change the name 3 times.
correct,
Yeah.
correct.
And I think they changed the name after you had submitted your session details to OpenClaw now.
Yes, even I have done my for the demo purpose, I have changed all this command line interface and all those things. So earlier it was like CloudBot, now it's known as OpenClaw. So like they have changed 3 times because of the trademark, I guess.
Exactly. Yeah. And the guy has joined OpenAI now. So,
Yes, yes.
so yeah, I mean, over to you. You can start with your intro, and the stage is yours.
Sure. So first of all, my name is Amin Ali. So I have overall experience for 7 years. So mostly I building the application in serverless using the serverless technologies, and even I'm the part of the company that is uh, Target Australia. I'm working as a software engineer over there. And so yeah, pretty much that about me. And yeah, so we'll share more details in session itself. Yeah, thank you.
Yeah, you can share your screen and then we'll be off
Uh,
the stage.
sure. Okay. Okay, so my
Yeah.
screen visible, right?
Yes.
Okay, cool. So, okay, so first of all, good afternoon, everyone. So today I'm going to show you how we can build our own personal AI assistants using the modern agentic technologies like Moldbot or OpenClaw. You can say that, like, so earlier they have changed multiple name because of the trademark, and we are using the Amazon Nova. Basically, that is the foundation model of the AWS Bedrock. So before starting this session, we'll move from simple chatbot to autonomous AI agent that can take action, automate the workflow, or interact with the real system. So in this session, basically, I will walk you through this work, how it's work, and how you can build one yourself, right? Securely and practically, basically. So, okay, so I'll go to the next slide first. So first of all, I'll talk about the myself. Like I'm a software engineer at Target Australia. I'm the serverless practitioner and passionate about the solving real world problem and experience in building this scalable system, mostly in AWS. And yeah, so that's pretty much about me. And so before starting, like, this all are the agenda which we are going to cover in this session. So first of all, we'll talk about the OpenClaw and then Amazon Nova, because these are the primary two tech stack which we are going to use it. And then we'll talk about the security and IAM installation, and then we'll deeply dive to the live demo. Okay. So yeah, so first of all, we'll talk about the problem statement, right? So why we need to use the that open claw, right? So let's start with the problem first of all. So we know that most AI tools today are passive, right? So we are giving the prompt and we are getting the response, right? So they are answering the question but don't actually doing the work for us. So developer and teams still spend time on repetitive tasks, basically. It's like managing their workflows, fetching data, running automation, and handling the cloud operations, right? So what we really need, even AI assistants that can think, decide, and act on it, right, on our behalf. So that is the reason, like, so that is the reason for Moldboard or OpenClaw is coming to the picture, right? So basically, most AI tools are passive. That's what I said, and it's giving the team spends time on repeating tasks and fetching the data, running automation, and manual and error prone, right, and handling the cloud operation. So that's the reason we're going to use the OpenClaw. Okay, so agentic AI assistants, right? So we'll talk about the solution overview, basically. So this is where the agentic AI comes in, right? So basically, by combining the open claw orchestration agent capabilities and the foundation model of the Amazon Nova, so we can build a personal AI assistant that can understand our user intent, connect a real tools, and execute action autonomously, right, and learn from the workflow as well. So in simple terms, we can say that, like, we are giving the AI hands, not just a brain. So here brain, we are using the bedrock models, that is the Amazon Nova, right? Now, like, so we'll talk about the orchestration AI agents, right? OpenFlow, right? So first of all, I'll talk about the OpenClaw is a source of framework, right? Open framework, right? And first of all, we need to understand the architecture at high level, right? So first of all, we need to understand the user interact with the AI assistants, uh, and the malt board orchestration the workflows, and OpenClaw act as an execution agent. And the foundation model we are going to use it that will provide the intelligence out of it, and other external tools and API can perform the real action. So this is the basically modular design that makes the system scalable and extensible and production ready. Okay, so now this all the power of the OpenClaw. So OpenClaw using the local gateway. So it's actually act as a secure bridge between your local machine and to the Amazon Bedrock. That for the foundation model we are going to use it. As I said that this OpenClaw known as Maltvault earlier, and now it's actually known as OpenClaw. It provides full data and for the your AI workflows, and it enables the step reasoning tool usage, multi-process natively, right? So now the Amazon Nova. So we talked about the OpenClaw. Now we'll talk about the Amazon Nova on the AWS Bedrock side, right? So basically, Amazon Nova is the foundation model, as I said, of the AWS Bedrock, right? So it helps us to build a chatbot and AI assistant. So it's a very newly foundation model of the AWS Bedrock. It will help to generate the text and summarize the all those text and content, whatever the response we are going to get it, right? And it understand the extract instance from the document itself, and it can automate the workflows, and it's a fully managed service, right? No GPU hosting or model training is required, and so we can privately and securely we can use the data inside our own in AWS environment. So it's very easy to use, and we can choose the multiple Nova model if there. It actually depends on the business requirement. What are the models we are going to use? So in this one, we have used the Nova 2 models. So we'll tell you for Amazon Nova 2 performance, basically why we have used this one. First of all, 1 million context length is there. It can handle the massive data set, and there's a multiple model efficiency is also good, and it's also a cost efficient, right? So first of all, while doing anything, we need to come up with the security and other thing the cost efficiency also be a major factor that how we need to choose the model on the based on the requirement, and if having a reasoning power as well, right? So it's having a level of the thinking, like how on based on the input it can think on it, and it will give you the response as well. Okay, so now so first of all, before diving to the demo, first of all we need to understand what we are going to build in the demo, right? So first of all we're going to create the IAM user uh, with Amazon Bedrock full access. First of all, I'll give the full access, but it's not a good practice, but for the demo I'll use that, and we'll use some generic CLI access keys from the IAM. We can generate that, and we can install the CLI installation package for the because in your local CLI, your cloud pod or OpenClaw latest package should be installed. Then it can talk with your open and that Amazon Bedrock Nova model, right? So then we need to configure the credential and register the Nova model in the local Jeffin config, and then we can execute the restart the daemons and all those things. We'll walk through you all those things step by step. So first of all, other thing we can configure the AWS permission. We can give the dedicated user for the OpenClaw user, and then we can attach the full access. This managed policy by the AWS providing. We can use that. We can attach that policy to the user, and we can generate the CLI access also, and we can ensure that in which region it actually supported. Amazon Nova is not supporting in every region. Some of the region is actually supported. For this demo, we are going to use the US East 1 region. That's North Virginia. So before, okay, so other thing, like CLI installation and onboarding will be there. So before starting, first of all, the prerequisite is there, like your Node.js version should be 24 or later, and other thing like npm package will be going to be installed the open claw for you, and it can execute the onboard to launch the interactive widget. Also we can able to see of the open claw, and then we can select the model, like what are the model we are going to use for the open claw. So as our primary model providing during the filtering step, we can select the model. Okay, so first of all, defining the model configuration, right? So to enable the Nova, we need to modify our local config. So right now you can able to see cloudbot.json, but as of now the name has been changed. So it's now like we can rename this cloudbot to the openclaw.json. Wherever you can see the cloudbot, we can rename with the openclaw, so it will work for us. Okay, and then we'll verify. After installing all those things, we can verify the launching it's actually working properly or not. We can restart the background process with the open claw, and we can restart the daemon, and we can apply the JSON changes what we have done in the config file, and then we can also do some authentication with the Amazon Nova, right? So whatever the credential or secret key we are going to create it, that will be going to use for the authentication. That's a trust relation with your open claw and the Amazon Nova, right? So and then we can use the terminal UI which is provided by the open claw, that is known as open claw TUI, terminal UI, for full screen and chat experience. We can fill that while using that one, and yeah, so we can use those things. So first of all, we'll deep dive to the demo. So as I said that this the slide which I have shown you, even I have done the blog for this one. If anyone would like to go in deep details, like how we can configure all those things step by step, we can use the blog. So I have one of the blog which I have created. So here you can see that create your personal AI assistant with Maltbot, but my this blog is not updated yet. So as I said, Maltbot now it's known as OpenClaw, right? So I'll update as soon as possible. But only the thing is that wherever you can see the Maltbot, just rename this with the OpenClaw. And yeah, so first of all, the prerequisite is that we have to have the AWS account, which is active, or you can, if you are a student, you can create your free tier AWS account, and the Node.js 24 is actually required for the system, right? So first of all, I'll go to the AWS account I have already opened. So first of all, we're going to use those things. And so, yeah, so first step would be create the IAM user. So I'll go to the AWS console, and there is one of the service known as Identity Access Management, that is IAM. So here, what we need to do, we need to create the user first, right? So I have already created the user, Maltbot, but you can also create a new one. While creating the user, just give the name, and suppose like I have given something like open claw. Okay, and I don't need the AWS management console permission. I don't want to give. It's an optional one. If anyone use this user as a user and password, they can use the same credential to log into the UI of the AWS account. Okay, so I don't need that because I need the CLI as well. So suppose I'll go to the next step, and I will attach the policy directly as per the document recommended, right? We can create and we can attach the policy. And what are the policy name is that Amazon Bedrock full access. As of now, I am giving the full access, but it's not a good practice. If we are using the Nova, we can granular the access as well. But for a quick one, I will use this one. Okay, so and for the best practice, like never give the admin full access, okay, because OpenClaw can able to do anything with your account. Okay, so because these are very new tools, agentic AI, and we don't know like what will going to be happen in future, right? So only we have to very understand like how we can manage the security claw, OpenClaw. Okay, so now next thing is that I have the Amazon Bedrock full access, and then I can create the user. So user has been created, and now you can see that earlier it was Moldbot, and now we have the OpenClaw as well, right? So as per the documentation, we have already covered this one, and now we need to create the access key. That access key will be your credential for your OpenClaw. And now we need to create this security credential, right? So now we need to go to the access key level. So if I'll go here, and if I will come here, I have already created mold, but I'll show you that I have how I have done. I'll show you that in the OpenClaw itself, and we'll go to the security credential, and in the access key there nothing is there. I'll create the new one. Okay, so in this use cases, my use cases is only with the CLI. Okay, so I will use the command line interface, and then I will I will give the confirmation, and then I'll go to the next. Okay, and you can give the description why we are using it. As of now, I'm just giving like this one. I'm using for demo. Okay, so I have created the access key. So after created the access key, this will going to show you only one time. Okay, so you need to download this one. Okay, so download this CSV. I have a CSV, and you can download it and you can use it, because only one time it will be going to show you. Another time you cannot download. The download option will be not there. Okay, so better you can download in your local computer or save somewhere else. It's for betterment. Okay, so this one I have already done for. I'll not going to create, but okay, so let it be. I have downloaded. Okay, and now I'll going to open claw and user. I'll not use the open claw right now, but I have shown you that how we can create for the same thing which I have done for the mold bot. Okay, so I'll use the mold bot over here, and in this one we have done the same thing, and now the installation and the onboard of the mold bot. Okay, mold bot OpenClaw. Okay, so first of all we need to check the node version. Okay, so I'll come to the terminal, and first of all I will use the I'll just make a big one, this one. Okay, so first I'll check that this version is available in my machine or not, right? So you can see that I have already the node version 24 is there. So for me it's good to go because I have already done. If it is not there, you can install with the npm file package. You can install the latest node version. Okay, and other thing, like I have seen that this is already satisfied with me for this version. So now we need to install the npm install cloudbot latest. So for me, it's already installed. So what we need to do right now in this blog, cloudbot is there. Only you need to change that the name. I need to paste it this one, and I will just change the name cloudbot to the OpenClaw. Okay, so this is changed. I have already installed. It will be say that it's already installed, but let's see what's going on. Okay, so it's installing, and I have already installed this one, but it will say that requirement is already satisfied. So let's see what's going to be happen. Anyway, so meanwhile it's actually installing. Okay, so this is some updation is happening. So meanwhile we'll check that next step what would be. We can see that after installation, right, we can see the CloudBot version. So okay, so let's complete this one first step, and we'll copy this one and we'll see the version at fill.
Hello. Sorry to
Yep.
interrupt you again.
Yeah.
Uh, 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 we only able to see your vlog screen. If you can share the terminal as well.
Okay, okay, 1 minute. Terminal is not able to see.
Yeah.
Okay, let me check. Okay, I'll share again. Okay, so let me know you can able to see my terminal or not.
Yes, we can see.
Okay, cool. So I will make this one little big. Okay. Okay, so I'll go to the blog. Okay, so the cloud bot is already installed. I will check the version of it first of all. Okay, so now I will change this name to CloudBot to OpenClaw. Okay, so it will give me the version. So right now you can see that the version
I
is
mean, I mean, can you increase the font size of the terminal as well?
sure, sure. Okay, it's okay.
Yeah, now better. Yes, thank you.
Cool. Okay, so we can see that OpenClaw version is 2026 2.26, right? It's actually giving the date. It's a nice thing. Okay, we can see that when this version has been added. Okay, so now the next thing would be we can install the domain. So you need to install the domain. So starting the onboarding process, and it will ask you some of the things I have already done. So first of all, it will ask you the accept the security notice and choose the manual onboarding mode, and it will ask you the local gateway, this machine, right? So local gateway if you're like local machine or local hosting that we can say, and the best practice is that uh, OpenClaw have their own port number that is recommended that we cannot use that. You can use your own machine port number. Otherwise, because we can't give those port number access to the other external publicly internal internet, right? So we need to make sure that, and then we need to set our workspace directory, like because this is actually worked on your user data. So okay, and we can skip the model authentication provider setup for now, and then other thing will be going to be asked like filter the model by selecting the Amazon Bedrocks, because like OpenClaw is supporting multiple models, right? It's Entropy models, Open AI, and it's also having the Amazon Bedrock will be often. Therefore, multiple often would be there. So we need to select the Amazon Bedrock because our requirement is that Amazon Bedrock would be our model. So for the foundation model, we're going to use the Amazon Bedrock. Okay, and for the model, for example, like we are going to use over here Amazon Bedrock, Amazon Nova Lite V1, and this Amazon Nova 2 is there. Earlier I have used the Nova, but I have used the Nova 2. Okay, so that's a better one. You can use that and accept the default gateway. As I said that this the 18789 is the port of the default one. We never use the default. Earlier I have used that, but multiple news which came that best practice we don't have to use this one. Okay, so we can use the another port of your machine. Okay, and then complete the remaining prompt and do it. Then you can just select that, do this later as you prefer. Okay, so other after doing all those things, first of now we need to the credential what we have installed, right, what we have created from the AWS IAM user, we need to configure this one in our local machine, right? So in this way, right, we can able to see, right, in this way we just copy this one and just paste it in your chat, and just your access key ID and your secret key, whatever the downloaded I have done, the in the downloaded we have a access key and secret key, right? So only you need to copy that and paste it over here, right? I'll show you that this configuration later. So just we need to replace this access key and secret key, and make sure the region must be the same region, US East one, for the Amazon Bedrock and Nova models. Okay, and once the file have been saved, we can able to use the credential for the Amazon for the open claw. Okay, so you can see that these all are the configuration is there, right? If I will go here and I will just type this one configuration in my terminal. Okay, so instead of this one, I will show the nano over here, just to show this one. Uh, Sorry. Okay, so this one, okay, we'll use the same thing. Okay, cat is not working. Okay, no such file or directory. Okay, sorry. So why it's not working? Because the reason is that I said that CloudBot is not recoverable, right? I have used the OpenClaw over here.
I mean, your screen stopped sharing.
Okay, let me share again. Okay, now it's visible.
Yes, thank you.
Okay, cool. Okay, I'll use the same thing, OpenClaw. Okay. Okay, so I will open the next terminal. Okay, so I'll make it big, this one. So as I said that this is already installed, so I will go here and so only we need to just use this one. Okay, so now I will so this is always stored in this directory in this level. Okay, and we can create an update on the based on the requirement, and then now we need to use this one. So I'll show you that this one in this console itself. I'll use this CloudBot to open Claw. Okay, so we can see that configuration, right? So I'll go to the iMod. Okay, so we can see that in this model we have used the Amazon Bedrock runtime US East 1 region, and in this configuration we can see the ID and the agent, what agent we have used. We can also able to see that. So model we have used the Amazon Nova 2 Lite, right? And in this one Amazon Nova 2 Lite V1, and then you can see the workspace directory. And so these all are the configuration we also can able to change. Suppose like you wanted to use Amazon Nova 2 or Nova 1, we can also change this name as the version itself from here, and we can just save it and we can restart the daemon. Okay, so we can see that this already done. uh, so now we need to go back from here. One minute. Okay, so we'll go to here. Okay, let me open the new one again, and okay, so now so we have already seen that the follow the configuration is already we have there. We need to use this configuration. You can see that we need to add the following configuration because I have added already, right? Because we have already done this one. So for your case, just copy this one, and in your case, like you just need to add this one to the existing, and after merging those things, after adding, you can able to see this configuration like this. Okay, so after doing this one, we need to restart the daemon. Okay, so suppose like if I'll go here, and if I go to the terminal, and I will just paste this one, and instead of CloudBot, I will use the OpenClaw. Okay, so daemon will be going to be restarted. It will take some time. So every time you're going to restart it, OpenClaw will give you the some information, like interactive information you can enjoy as well. Okay, if here you can say give me a workspace, I will give you the fewer tabs, fewer toggles, and more oxygen, right? So it's very interactive. So it will take some time. So what would be the next process? We can go here, and after the daemon will be going to be restarted, we can also check the what are the domain CloudBot model list we have already configured, and after we can also see the list of you step by step. So first of all, I will copy this one, and if I go here, it will take some time. Let's wait for some second. Okay, so it's restarted, and now we need to see the models, which model list, like for the OpenClaw. Okay, so
Your screen again.
I'm not sure why it's happening. Okay.
Yeah.
Okay, good. Okay, cool. Okay, so right now I have used this command to lift all the models, like not lift all the models, the model which we are using right now, currently what we have configured. Okay, so here we can see that we have used the Amazon Bedrock Nova 2, and the input is text plus image, and CTX is 29293K, and local is no. So here you can see that authentication is yes. It means that the authentication, the credential what we have created from the IAM user and what we configured for the OpenClaw, the authentication is established successfully, right? And it's also configured, right? So that is the good signal, right? We can, it's already done. And then other thing, we can use the so other also we can use the model list. What are the model list is available in CloudBot. Okay, so I will use the model list all, and here you can see that the all the models. Here you can see that there's a multiple model is there available for the OpenClaw. We can use this right now. You can see the no is there, right? Everywhere no, because we haven't used that one. and whatever we have used, that's a local if nothing auth is there, right? So we can see that Amazon Nova 2 Lite, we have configured this one, and it's actually uh, default one which we are using as of now for this one, right? And other model is also because only we have configured for the Amazon Bedrock. For that reason, we can see that yes, if there a part of that other model is also there, Anthropic, like Azure OpenAI, we can use GitHub Copilot and Google Gemini. There's a multiple. On the based on the requirement, we can configure other model as well. Okay, so other thing like after this one, we need to use the TUI. That's for terminal UI. Okay, so now we'll go to the uh, terminal, and I will use the TUI. Okay, and now I will enter. Okay, so so now you can see that I have already asked some of the question, right? So first of all, whenever first time you can open the TUI, it will ask you some of the question like what you wanted to call the this AI assistant, right? You can give a name over to them, and AI assistant will ask you that what should they called you? Okay, that also name you can give, and it will ask you other question like how they can help you. So it can be configured, it will actually create your identity.md file, and on the base on that information you can able to interact with your AI assistant, right? So right now I will ask hi, so it will running. Okay, so it will give me that some response because it's already, so it say that hey Amin, right? Because he already know my name because I have already given that you called me the name. You whenever I will talk with you, you can call me with Amin name, right? And I have given this AI assistant name is Buddy. Okay, so that is the reason is showing that Buddy is here, casual and friendly AI assistant at your service, right? So other thing like if I will ask like what models you are using, right? If I will ask to this, what models are you using? So it will tell like what model, because currently we are using the Nova 2. So it should tell like, so he's saying that, hey, Amin, I'm using the Amazon Bedrock US Amazon Nova 2 model. This Amazon Bedrock, it will give you the full information. And so it will also saying that like I'm running within the OpenClaw interface, which given access various tools capability to help with tasks, right? So in this way, like we can able to build our own AI assistant. So these the terminal, there's a other UI interface you can able to build out of it. Okay, so if you wanted to go deep dive and how you can connect with internal tools as well or other external tool as well, Telegram and other thing, but that tool also can be accessible while using the OpenClaw. Okay, okay, so this the way we have done. Okay, so right now if using the brain of the AWS Bedrock, that's the Amazon Nova. Okay, so this pretty much about this one. So other thing like suppose like in future if you wanted to change the model, so in this with this command we can also change the Amazon Bedrock and suppose like in future you wanted to use the Amazon Bedrock Anthropic model. Okay, foundation Anthropic foundation model. We can also directly change the model with this command. Okay, and so in this way we can able to do we can build our own AI assistants. Okay, and other thing like I'll go to the slides. Okay, so so we have already.
Sorry, your screen stop sharing again.
I'm not sure. Okay, okay, now it's okay. It's it can visible, right?
1 second. Yes, no, it is not visible again.
Okay, let me share the screen now.
Yes.
Okay, cool. Okay, so as of now, we have seen that how we can configure the OpenClaw with Amazon Nova model, and other thing there are multiple tool is coming up, multiple agentic AI is coming up in the market, right? So before using this one, we need to follow the best practice. So to always so as I said that always keep the gateway private, never expose the publicly, and always apply the least privilege, because it will allow the limit to the for to the limit the API and file access, right? And the best practice right now, I have used the local machine, but the best practice would be always run in a sandbox account, right? We can use the Docker, or you can use your dedicated VM or EC2 instance, you can use that. So in that way, what happened, right? Your private data will be secure. And other thing, like never use this OpenClaw in your enterprise laptop because it will be in risk. So it's very new and it's not mature to use, because these are the uh, open hub is also there. OpenClaw have an open hub where multiple repository and project is actually keep contributing by multiple people, right, as an open source. So it's better that you don't have to use those things, like always follow the best practice. And other thing, we need to protect the secret store in always secret manager. As of now, I have used the use secret manager is one of the service of the AWS, where you can use the very sensitive credential have in the secret manager for the best practice and for the security purpose. Okay. And always require the human approval for the risky action, right? Or not, don't rely on the AI, any tools and all those things. Okay, on always install the trusted skills, because there's a multiple skills is provided in the Open Hub. So always review the plugin before enabling those things. Okay, so these all are the thing which we have to keep in mind while building the AI assistants for our daily use cases. Okay, so that's it from my side. Yeah, thank you.
Thank you. Thank you so
Yeah.
much, for showing us how this Nova Amazon Nova works with this personal assistant bot. And
Yeah.
it was really interactive session. And I think we have few questions in the chat.
Yeah. 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 So, I mean, the first question is from Raja Ravi. Does the free tier covers the Nova Lite model usage, and to what extent? I'm assuming he meant the AWS free tier.
Yes, correct. So I think because I know that this Nova model is basically the foundation model. So as a free tier of the AWS account, it will provide you some of the token to use it. Okay, so you can use it, but it will not give you the. But always try to use the billing alarm. Okay, so because in the AWS itself, we have a billing alarm itself. Suppose like your free tier will be going to be over, and then your money will be going to be charged, because in future the other billing generation will be going to be happen and you pay for that. But if you are a student and if you are a newly using the AWS services for the learning purpose, you always reach out to the support, they will give you a waive off. No worries.
Yeah. Okay. So one more question from the same person. Apart from the CLI, can that TUI functionality available or can be used as SDK to as use it a custom React app? I assume. Yeah. Use it in a custom React app.
Yes, so as of now, what I have, because these the out of the box which OpenClaw is providing, that you can, while building, you can test it as soon as possible while building on the go. Okay, but if you wanted to use this one in your React app, you can use it because there's a multiple, because it's a open source. If a open library is also there, you can reuse that one in your own application itself.
Awesome. Um, so I guess that's all the questions. If anybody has any question, they can mention it. And in the meantime, I mean, you already mentioned a couple of things to be careful about, especially given the security
Right.
concerns that people have had in the past as well. So one is the enterprise laptop, your work laptop, or that for that matter, don't really run on that. And you also mentioned about the plugin. So are there any other things that one should be a lot more careful about when we are using this, because it literally has so much of control?
Correct, because it looks very cool, right? Because because this AI agent can do something behalf on you, but the thing is that always try to control those things within you, right? Don't give those control to the AI. For that reason, in the security slide, which I have already shown, that other thing like the port number, because OpenClaw have a default port number 1879, I guess. That is actually being used publicly as an internet. Also, it can be used accessible. Okay, so always try to not use that port basically. Okay, so because we I have seen that from last 2 3 days or last 1 month, there's a multiple attack has been happened in the OpenClaw itself. So because of this, it can be easily accessible by the internet. Okay, because there's a multiple contributor is there. They are using the plugin, they are updating, because it's an open source, right? They can come and they can contribute. Okay, so because they can access your computer data, so it's better to use your own private other thing, like which I have said, that always use the sandbox account. Never use your own personal laptop, because suppose like in future, if you are logging somewhere in your bank account and all those things, it will keep track all those things, right? So it's better to have those things in your sandbox account. Use the VM run, VM based virtual machine, you have to use it. And always even itself, right? While using the virtual machine, also keep in mind that what are the access you are giving, right? With the best practice, always use the IAM role and give the permission what are the access you are giving, because if your AWS account itself is having multiple sensitive data, they can also reach out to them also. So for that reason, always the best practice, always keep in mind security is the major factor here.
Right. Right. Perfect. Yeah. Thank you so much, Amin, for joining us on a Saturday morning. It was really insightful, especially the setup part for people who have not used OpenClaw or are interested. I think this would have been a great session. So thank you. Thank you so much, Amin, for joining us today. And I hope to have you again soon, sometime in the near future.
Yeah, sure. Thank you.
Thank
Bye.
you
Bye.
so much. I mean,
Bye.
bye.
So yes, so that's it for the session today. We hope that both the sessions were insightful. They are something new, especially the second one is on the rise, and the first one is a new feature, which is kind of trying to replace step functions in some ways, bringing the features into the code itself, which is much more easier as developers because we don't have to understand. Writing the workflow, the orchestration in a YAML or a JSON, and makes it a lot more easier for us to it's more native, right? As Jaya mentioned, it's the language that we speak, and that makes it a lot more intuitive for new developers to get used to it or get started with. So yeah, if you have not already tried out durable functions, go give it a try. It's really cool, especially the callback pattern is certainly really cool.
Yeah, and we will come back with a lots more interesting sessions, like which you are doing in your day-to-day life, in your workplace or in your personal. We will come up with such sessions, and also as Susit mentions, we will be sharing the new event details which is happening in Tirupati. It's offline session. Yeah, very soon.
Yeah, so I've shared the link, and whoever is interested and sure of attending, please do RSVP. It's a free workshop. So we will be doing on Kiro, the agentic IDE, on how we can leverage AI to build. Build features and not just use it for autocomplete. So that's the crux of it. And as always, if any of you are interested in presenting at our meetup or a session, please do reach out to either Dharmendra or me. We'll be more than happy to host you. It doesn't matter if you have experience or do not. It's important that you share your knowledge with the community, and that's how all of us learn and grow together. So that's it from our side. We hope you had a really great, insightful Saturday morning, and wishing you a great rest of the weekend. Thank you so much for joining us today. See you hopefully next month.
Thank you.
Thank you all. Bye bye.